Yeah, COS2614. We want to look at classes, which is
Yes.
going to be an interesting journey because this is where, um, yeah, the real stuff starts. We've looked at input dialogues, message boxes, generally how to write the code and getting comfortable. But now we get into the crux of the
Mhm.
matter. Let's quickly open our Qt Creator here. And meanwhile,
Yeah.
that's opening. Let's quickly understand what's going on with this question. Right. So we've talked about functions and said functions are a way of organizing your code, right? And the reason why we
Mhm.
talk about object-oriented programming is actually because of what we are about to discuss right now. Okay, let me just get this thing to respond. I don't know why it's not responding. Let's see. Okay, perfect. So before we get into this question, I would like to, I think, um, explain something quickly that should give us a background of what classes are and what we want to do. So the reason why we talk about object-oriented programming, or just in short, or OP, I'm sure you've heard about this, is that
Yes.
before we just had functions. You write your code and then any bit of code which does something, you'd sort of like abstract into a separate function and then you just call that function. Now,
Mhm.
classes take us a step higher, which
Yes.
means object-oriented programming is simply programming which is oriented towards objects. In other words, I mean that we treat um, items as real-world objects, right?
Mm.
And what do we
Yes.
mean by that? Whenever we are trying to solve problems, we are going to have um, objects. And how do we define, like when you say an object, what do you mean? Now, if we talk about real world objects, we can talk about a phone as an object. We can talk about a pen as an object. We can talk about a car as an object. Now, if we apply our minds in that context, we can then say, well, a phone has functions, right?
Mhm.
And pardon the pun, but I think it'll help. You can use a phone to make calls. You can use a phone to text, and you could use your phone to, let's say, play games,
Yeah.
right? You could use a pen to write. These are functions. You can use a car, you can drive a car, you can park
Sleep
a
in a car.
car, you could wash a car. Functions. So with that mentality that we have around, you know, objects, we are saying that an object allows us to do something, right? In other words, you wouldn't use a pen to make calls. So when we start designing applications, now coming back to OOP, right?
Mm.
We we start identifying objects within our problem space. Like, what are these objects in this problem we are trying to solve that can allow us to group certain functionalities together? So, whenever you want to perform related operations, you are most likely going to group those operations within an object. And then you can use that object to do, whatever you want that object to be for, like in this case.
Mhm.
So if we had a problem space that said we need to make a call and then, take some notes from the call and then go somewhere, we could say, well, we need an object that can allow us to make calls. We need something that can allow us to take notes, like writing, and then we need to be able to move. And in solving that problem, we end up with three objects: a phone, a car, and a pen, for instance, right? And
Mhm.
that's how we apply our thinking towards classes. So whatever we are calling an object here, when we get into programming, these are what we are referring as classes. In other words, a class becomes an object that has certain functions. Now, I'm using the word function here in a pun intended of way because we do have functions, like actual functions within classes in programming, which you know. And I'm also
Yeah.
saying those functions are meant to carry out certain operations that are related. And in designing classes, when we start, we are going to be given what object to create and what functions to include in this object. One of the most important things I want you to remember when, diving into this is that let's talk, for instance, about our phone. And let's forget about everything else. Let's just focus on the phone and let's talk about calling, right? So a phone allows you to call.
Yes.
But what really happens inside your phone when you make a call? We actually don't know, right?
Yeah.
There is something in there that for some reason takes the number on the screen and connects to some network tower. I don't know what tech they're using, but there's a bit of stuff that happens inside the phone that allows us to connect to that number. There's tech involved, right? So
Yes.
the mentality I want you to have whenever we are talking about objects is that there is certain stuff behind this phone which is private to us, things we
Yes.
don't have access to. In other words, we actually don't care how the phone does it,
Yeah.
right? But
Yes.
what the phone gives us is something that is public, which
Yeah.
is what we can access, which is this function here. So that leaves us with two areas, stuff that's private and stuff that's public. Public is whatever is within this object that we can access and use. Private is whatever is within this object that we don't have access to. In other words, we actually don't know. We don't care, right? Now, the reason why we're having this discussion right now is I want you to understand two things as we start creating these objects, which we said are classes. Whenever we are creating a class, we are going to be doing one of two things. Number one, are we actually creating this phone? Or are we actually using this phone?
We're using the
With,
phone.
from my experience, whenever we introduce classes, this is where most of the confusion comes from. People trying to make sense of this code and just not knowing which code goes where, right? So I need this to be very clear in your mind that as we, delve into this topic, creating classes, we're going to be either creating this thing or we are using it. Now, the reason why it's important to understand where am I is that it allows you to think of the right code and apply the right principles, because we've got certain programming principles that we are going to follow when we are here, and a different set of principles that we are going to follow when we are here. Different. Now, we're going to start with here. Let's create a phone. Now, in creating a phone, we need to decide what's private, what's public. What is it about what we are doing that we don't want anybody who is going to use this phone to even know about or access? Which means, as part of creating a phone, we're going to decide what's private and what's public. Now, this decision is very easy to make, but I just need you to understand why this happens. So as we create our classes, you're going to see that for starters, it's going to become obvious what becomes private because every single time those particular things are always private anyway. And what becomes public, but the concept of public and private, I need you to understand that whatever we make private, we are saying this is concerning how this phone functions. It doesn't concern who is going to consume or use it.
Mm-hmm.
And in most cases, you're going to realize that whenever we introduce functions within a class, most of the times we make them public because we want anybody using our object to be able to use those functions or operations which this class is meant for. Right. That's the
Mm-hmm.
general idea. And as we program, we create a lot of these objects and we start using them together. This one references that one, this one references that one. And eventually, these classes that we are creating, when we start using them, are going to be nothing different from the variables that you've already been using. For example, in our previous section, we talked about queue input dialogues. We talked about a queue string. All these are just classes, but these ones are predefined. These are part of the framework. We've already used some of the functions, for example, the split function with
Mm-hmm.
the count function or the len
Joy.
function, right? The only difference is this class already exists. It's a predefined class. It's created. It's there. We can just use it. What we are
Mm-hmm.
doing now is creating our own classes. Once we create them, we are just going to use them like any normal variables. That's pretty much about classes. So when we start, we're going to be told what object to create, what functions to add, what to make private, and how to use that object. Very simple. It's clearly defined. We are being told. And for the rest of this course, every single class you're going to create, you will be told which functions to add, what those functions should do, and whatever needs to be private within that class, which means in this course, you are spoon fed everything. Your job is just to understand and know how. Do I use this class? How do I create this class? So we never have to worry about what functions do I need and why, because all of that is provided. But as we
Okay.
advance and go into the next courses, you'll get to a stage where you have to define your own classes, decide which functions you need to add, and then go ahead and create those classes. But for now, our life is quite simple. Just create a class, do what it says it should do, and use your class. Done. All right.
Okay. Yes.
And we are going to talk about other concepts relating to classes like inheritance and all of that. But
Mm-hmm.
generally, that's the idea behind classes. And to learn about classes, let's use this question, which is was part of one of the assignments, which we did. But now let's understand it. Okay.
Sir,
Design and implement a simple
sir,
application that models an online store inventory system based on the requirements and class relationships described below. So everything is given. Class descriptions. In other words, what classes or objects are we going to create? Number one, item. Number two, vendor. Number three, store item. So in this case, we're going to create three classes, right?
yes.
And we're going to go into the details of what each one does, what each one requires, and how to do them. Item is the first class. Item
Sir,
represents
Mr. Edmund.
a generic item sold in the online store. Each item is characterized by a unique identifier ID, a name, and a price. The item class will provide methods to get and set these properties. Additionally, it should include a method to print item detail. So what they've
Sir,
done here,
hello?
given us the name of the class, they have given us the functions that they need, and these are referred to as methods. You will see that at this level, methods and functions are used interchangeably. But in other languages, methods are different from functions. depending on the platform that you are operating at. But otherwise, for now, we are just, oh, I think you're trying to say something. I'm not hearing anything because my speaker is not set correctly. Thank you for the message. I should be able to hear you now.
Can you hear me now?
Perfect, perfect. Sorry about that.
Okay. I was just saying that I don't know if you were able to see it on Telegram. I attempted to do the class for the item part, so I was hoping we could take a look at that.
Oh, perfect. Yes, definitely, definitely. I'm gonna jump into that and look at it. Yeah, but let's just finish this explanation quickly, and then so that I don't have to re-explain anything as we go through your attempts. Yeah.
Okay.
So we are given all these methods, which yeah, which we should introduce. And in this case, they said we need functions that allow us to get and set these properties, right? You're going to
Yes.
realize that get and set methods are very common in classes. These ones are normally called accessor functions. These ones are normally called mutator, or sometimes just set functions. But generally, these are very common, and you see why as we go on. So that these are the ones they are requesting here. Then we need another function that allows us to print item details. This is usually a function that returns a string with all the details within that function. Now, all these attributes within a class, the identifier, the name, the price, these attributes of your class are always set as private because the information that your class stores should remain inside that class. It should never be directly accessible to the outside world. So you notice that every time we're given attributes, those ones we always keep private. Functions, however, these ones we always keep public because that's what we want everybody to access. So your get functions are the ones that allow you to return the values of your attributes. Your set functions are the ones that allow you to set the values of your attributes, but the actual attributes themselves, you always keep private, right? Okay, so that's basically about functions. Now let's go and look at your attempt on functions on classes, and then we can see if you are actually covered there. Is it under
COS 2614.
the actual group? Okay, let me go there quickly. Okay, there we go. Class info. All right, perfect. ID name price. Okay, let me just copy your code here. And then yeah, let's just copy your code for that. So what I'm going to do is create a new project. It's a console application. I'm going to call this one intro to classes. And then let's put this inside COS2614. Next, 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 finish. So here, what you'd normally do to introduce a class is once you just go to your project, you right click and you say add new, and then you just go, I want a class. Then my class is called item, so I just call this one item. And then I go next, finish. This would put a class in my, if I'm using CMake, you have to paste it here if it's not pasted for you already, depending on your version. If it's not pasted, you just go Control V, oh, sorry, and then you paste your class. But here it's done for me already, so I don't have to do anything. Now, I have a class which has a header and my implementation file. So what I'm going to do now is just go to main here and paste your code here, right? You defined a class, and your class here is called info, right? So
Yes.
mine is called item. I'm just going to copy all of this, right? Remove it from here. Let's leave the class itself out here. Go to my actual class and just paste your code in between here, right? Because mine is called item. So I'm going to paste everything here. Now it's going to say, I don't know about QString. So let's include QString. What else is it complaining about? Now it's happy, doesn't want So in Qt, we hardly use this here, or probably you went with, let me see, with your IO
I,
stream here.
yeah.
I think you did that. Let's see where that is. Okay, so yeah, you can use IO stream, but in Qt, just try to avoid using these items, this class here, unless we really have to, especially for displaying whatever. But it just depends. You can still use it though. It's not a problem. But yeah, that's your class, right?
Mhm.
So you identified your attributes and you said, I've got an ID, I've got a name, I've got a price, and you made them private, which is brilliant. So that's 100% what we wanted to do here. Perfect.
Mhm.
Then you said set name should set my name here to my name. Get name should return the name. We talk about that. You skipped it. Set ID should set my ID to I. Get ID should return the ID. We'll go there. Set price should set the price to P. Get price should return the price. And then print details should just display the details. Perfect. 100% in the right direction. Now, let's quickly just structure things perfectly here according to how your solutions normally go. You'd see that your compiler already does, your IDE does your header file, and it does your implementation file here. So usually you don't implement inside your header file. You normally do the implementation in your source file, which is here. All right. So let me just put the missing constructor here that was generated for me. Let's leave it like that. So what you'd normally do is you just leave this here as set name like that, just the function. And then if you right click this function and go refactor, add definition in item.cpp, the first option, it will go and create the actual implementation file here. So that code
Okay.
would then go here. Oh, sorry. So you then go here, name equals n. Same code, but you do it in a different file, your implementation file. So that's what you do also for this one here, this code here. We don't implement here. We just leave this as the header, just your functions. You implement your functions here. So that's where you put your code there, like that. So this way, your header files are simply just a list of your functions without the implementations like this. Your price, again, we just leave the prototype here. Get price, same thing. Let's go and do our set. Was it set price? The one that yeah, set price, refactor, add definition. That's where you put your code, which is correct. Then like that. And then print details, again, this goes into the implementation. This just remains just the function. We leave this here like that. We go into our implementation, refactor, right click, add definition. We put our code in here like that. So now you can see we just have our class and the header, nothing else. And then in our implementation, that's where all these functions are implemented, nice and clean. This is the approach that we take. And you see that in the exam, when they say write the class definition, they only want to see this. That's what we refer to as the class definition. We have
Okay.
defined what our class looks like. What
Mhm.
attributes does it have? What functions does it have? At this point in time, we don't care what these functions do, but we know these are the functions we need. So these ones are our get functions. Or we've got a get set, get set, get set, all of them. Now,
Mhm.
you didn't do your get name. Get name simply returns the value of your name. So all your get functions simply return your name. So just go return name like that. That's how you do them, all of them. They don't do anything else. So you do that for get name, get ID would just return the ID, return ID.
Okay.
Then get price would just return the price. So you go return price like that. So one thing you need to also do all the time is just constantly build your applications to detect any errors early. Don't write a whole bunch of code and then when you've got plenty of code everywhere, now you build and now you see errors and you don't know. at what point did you make an error? So it's good practice as you go through, as you do your code, do this, do that, do this, do this, do that, build. Okay, perfect. My class is fine. Then you can go to the next step. The other thing I want to mention also here is what we call naming conventions, right? Naming conventions are just a way of naming your variables, usually. And you notice that most of the times we use what's called camel casing, um, which means you capitalize every noun in your variable name. And you always start with a small letter, right?
Oh,
So
yes.
if it's name, I'll just call name like this.
Yeah. Okay.
So if you've got these already and you want to rename your variables, the same thing you did with your functions. See, set name, get name,
Yeah.
set ID. That's camel casing. So you've got the idea already. Now, if you want to rename your variables in Qt, all you do is you can just press Control Shift R like that, or you can just right click, refactor. Okay, let's just try that again. Right click your name, refactor. Why is it not giving me my refactor option? Okay, let's try again. Refactor. It's not giving me the option to show my options. I don't know why, but you can. There should be a rename option for refactor. But anyway, I'm gonna do Control Shift R on Windows. Then I can simply say change this to name. Doing it this way, and you say replace, it identifies everywhere you've used this, and it renames it for you. You don't have to go and find it everywhere. So if you go here, you see that our name is now lowercase everywhere. It just finds it and renames it for you. That's the safest way to rename your variables if you want to change. Um, I can do that for my price, Control Shift R. Then I go just make it price lowercase and then preserve my case, replace everything. And everywhere where there's price, it's going to replace it. If I build, it's going to say, yeah, it's still fine. Perfect. Now, that's the item class. Let's talk about one thing here that we need to get clear. Additionally, it should include a method to print item details. So in this case, they wanted to actually display those item details, which is fine. We can leave it as it is and did a good job. There's nothing to worry about there. Now, okay, just give me 1 second. All right, sorry about that. Okay, so the same idea that we applied on item, we're going to apply that on vendor, right? So let's see what vendor does. It represents a vendor supplying items to the store. Fine. A vendor is described by a vendor ID, a name, and an address. This class should provide methods to get and set these properties. The toString method should return a string representation of the vendor, including all its details. Everything else about vendor here is exactly the same as about item. The only new thing about a vendor is this toString function, which they said should return a string representation of all its details. So what this function does is it simply returns a string that says, here's the ID, that's the name, that's an address, but as a string. So your string can be like this ID colon, then you put the ID, then you say comma, then you say name colon, then you put the name, and then you go address, then you go colon, then you put the address, and then you return this string. And I'm glad we talked about how to build a string. If you remember that whole %1 story that we did, and then you go .arg at the end, and you just chain them together, that's going to become
Yeah.
very handy in building these strings. And it's something we do quite a lot. And this toString function is also something that you see quite often when we implement classes. So let's quickly do the vendor class, which I think by now we sort of like know what we want to do, name, ID, name, and address. So we can quickly just go here and go right click, add new class. Then we can go, our class is called vendor, just go next, next, next until it's done. Fine, it does that. Here's our vendor class. So when you do it like this, it just auto generates this constructor here. We'll talk about the constructor. So I can just go and go private here. I've got my Q string and yeah, everything is a Q string. So I can just again go include my Q string. Then here I've got Q string ID. I don't have to do 3 lines. I can just go ID, comma, name, comma, address on one line if I want, because they are all Q strings. I don't have to do it 3 times. But it doesn't matter. Yeah. Then sometimes people prefer just do it on 3 lines, so it's very clear what my data members are, but it's optional. Now we know we need get set functions for each of them. And you did a good, I didn't check one thing here. Your get name returns a Q string, set, get, oh, well done, good job. Okay. So we've got get ID, which returns our ID. So we can go Q string get ID. We've got Q string get name. We've got Q string get address like that. Then we've got our set functions, void set ID, which gets a Q string ID like that maybe. We've got void set name, Q string name or N. Then we've got void set address, which takes a Q string maybe A like that. These are my functions. Then we've got a string function, which returns a Q string. So we can go Q string to string, and it takes nothing. It just returns a string, which is a concatenation of all these things, right? And then very quickly, we can go and do our get ID. All these ones are going to do return statements. If I want, I can just right-click all of them, right-click, refactor, add definition in vendor. It'll just, I thought it's going to do all of them. I don't know why I did. Okay, it's fine. This returns, return the ID. Let's do get name, refactor. This returns the name. Then we do get address. Just going to do this very quickly. Return address. This sets the ID. I think you've done this already. So you're so ID equals ID. We do set name, the definition. So we go name equals N, set address, address equals A. Then we do to string, which is going to return a string. So you can go return Q string. Now our string, we can format it anyhow we want. We can go, let's go ID, then we put the ID here, the name, then we put the name here, then address, then we put the address here. Then we can just chain our args. So dot arg, the first one is going to be name, the second one, ID. The first one is ID, the second one is name, the third one is address. And you can put this on the next line. If you just want to format it nicely, you can do it like that. It doesn't care about line breaks. It's just formatting, whichever way you think looks nice. Then once you've done it like that, you can build, see if you've got any errors doing this class. No errors. That's our vendor class. Now, I'm not going to worry about syntax for this right now, but I'm going to show you another way of actually let's not go there yet. Let's stick to the story. So we've got our item and our vendor. Simple, everything done. Let's go to the next class, which is going to be our store item. Now we need to introduce the concept of inheritance. Okay, but let's read the question first.
So that's it. Are we done with vendor?
That's all.
I over thought it. Like I was just okay, let's go to store items.
No, yeah, exactly. So you might have
Honestly.
thought more than what was provided. Otherwise, you were not doing anything more than they said, because remember, they give you, that's why I said for this course, we never go into a level where we need to start getting clever and figuring out which functions we might need to add. They always provide us with every single function they need to add. In most cases, if we encounter a question where we've got to try and think what functions we need to introduce that the question doesn't already tell us, then I'll let you know. But in most cases, I think 99% of the times at this level, they'll tell you these are the functions you need. Just stick to the story, stick to the question, don't even try and get clever. So you see that for vendor, they said, here are your attributes. Your functions are these get and set ones, those ones. I said these are common every single time you do them. And here's another one, the string function, and that's it. So there's nothing more than our class with our get set functions, which are these ones, 6 of them, and then the toString function, nothing else.
Okay.
Yes, nothing else. Now let's look
Okay.
at the store item class. Extend, this one extends the item class. Now that's where things start to get tricky.
Yeah.
When we say we are extending a class, that's a whole new story. That's a whole new level, which is very important for our studies in this course because we are going to be talking about this concept of extending classes quite a bit. But let's start simple. This question starts simple, just so that we can just get the concept. And then we'll get to more complex questions. For example, that UMO class diagram that we discussed, but that's where things are going. But it starts here with a very simple example. But it covers the concept. And all we are going to do is do more classes, more methods, but the concept stays the same. All right. So we're going to extend the item class. Perfect. In addition to the properties inherited, now you see the word inherited being used directly here because the concept itself is called inheritance. Inherited from item. Store item includes a property to store the vendor, that's the supplier, of the item. Okay, so that's an attribute. So here they are using the word property to just define or mention what attributes are in your class or data members of your class. These are the things that they are calling your properties. These are just data members, all that stuff that goes under private. So here they are saying it includes another member variable called vendor, which stores the supplier of the item. The class should override. Ooh, there's another thing as well that we need to learn. What's overriding? The method, okay, to print item details to include vendor information if available. It should also include, oh, there's another method, get vendor name. So we've been given another one here that returns the name of the vendor if set or unknown if not. These details are about how we are going to implement this function. And there's a lot to discuss here. And let's start with one thing, extending the item class. What is this? And how does this concept work? Now, when we talk about extending a class, you are saying, I have here an item. Let me use this example to explain, actually, just to not shift you all over. I have an item here. And an item has everything I need, an ID, a name, and a price. Then you say, well, I also have an item, but this one kind of has more, but it's still an item. So you are saying, I have a store item in an item, right? Let's leave this here for now. And let's talk about a graduate, a student, right? So we can say, look, I've got a student, right? And this student is a name. They have like, an address, and let's say a cell phone number.
Okay.
Right. But then some students are undergraduates. Okay, you've got an undergrad. Okay, perfect. But others are postgraduates. Okay, fine. So you've got postgraduates. Okay, these are all students? Yes. Okay, fine. So undergrad, what do they have? Oh, they've got a name, they've got an address, they've got a cell phone number.
Right.
And actually, no, I'm doing this wrong. Let's forget about students. Let's just worry about undergrad and postgrad. And what else do they have? And they've got like their degree, which they are doing. Is that all? Yeah. Okay, fine. What about the postgrad? Oh, they've got a name, they've got an address, a cell phone number, and they've got a thesis, which is their area of study. Okay.
Mhm.
So now if we are designing a solution, we need to create two objects, one that represents an undergrad, one that represents a postgrad, so that in our program or application that we are designing, where we need an undergrad, we can just be like, okay, here's an undergrad, and we define our class undergrad. Where we need a
Mhm.
postgrad, we define another class called a postgrad. But then here's the question. If you look at these two types of students, you'll be like, they're kind of the same. The only difference is, well, this one is a degree, this one is a thesis. But they're students.
Yeah.
And then you're like, oh, can you not just have a class that represents a student? Um, sorry. Just hearing a noise. It's one of my dogs getting it. All right.
Oh.
So can you not just have a student? Yeah.
Mhm.
And well, because it doesn't matter if it's undergrad or postgrad, they all have a name, they all have an address, and they all have a cell number. That way, I don't have to repeat this information twice. It's taken care
Mhm.
of. So I've got this, it's a student. They all have this. So I don't have to repeat these things twice for undergrads and postgrads. But then if you take out all these things from an undergrad, what do we do now? Well, let's just extend this one and add a degree. What about a postgrad? Well, we can just extend this one and add a thesis.
And add a thesis.
So if I want, so what I then end up doing is I've got a class called student, which in this case is referred to as a base class.
Mm.
And then you extend this class and you end up with what's called a subclass, which
Yeah.
means postgrad is an extension of a student.
Okay.
And undergrad is an extension of a student. So when your compiler, once you extend your your classes like this, what your compiler is actually seeing when you tell it to make an object which is an undergrad, behind the scenes, your compiler is going, an undergrad is actually a combination of everything here plus everything here. So your compiler is looking at an undergrad as something with a name, an address, a cell phone number, and a degree, which means
Mhm.
behind the scenes, your compiler is simply combining the base class plus the subclass. But in your coding, when I'm developing my undergrad class, I don't have to go and repeat all of this. I just extend that class. This same idea is what you are seeing here between item and store item. So if you think
Mhm.
about store item, a store item has an ID, a name, a price, plus
Yeah.
a vendor. So the idea then is, well, in this example, because it's only one item, it doesn't really bring out why we had to extend item to store item, because then we could
Mm.
have just have one item. But it's just the general idea of programming. Like I can have an item, I can have a store item. If I end up with another type of an item, I can simply extend item and make that type of an item. Like here we've got undergrad and postgrad. So because of that, we don't have to repeat all these. We simply extend an item and then we end up with a store item. That is where the idea comes from. Now, how do we do this extension so that we can have a store item with an ID, a name, and a price? But ID, name, and price those we are inheriting from item. So we don't repeat them in store item. We simply inherit. So that concept of inheriting from another class, you do it like this. So you go, let me add a class here. This class is store item, right? Next, finish. There's my store item. I don't have to do anything here. So I go to store item. Then I say, well, I should include item. Now I want to extend the item class. So you go colon, then you go public item. This means inherit from or extend item. Just this line, this one line here. That's how you do it. That's inheritance, which means store item is inheriting from item.
Yeah.
Yeah.
Okay.
Which means by virtue of doing this, a store item now has an ID, name, and a price because it's at this level. So whenever you view store item is a combination of this plus whatever we are going to put in here. That's the actual store item. It's an extension. So it's this plus whatever we add here. So this way, we've now covered the part that says, in addition to these properties inherited from item, store includes. So they are saying, once you've inherited, please add another one, which is a vendor. That's the extra thing that a store item adds. But how do we add a vendor in a store item? Now, that's where I said, once you have defined a class, you can use it more like just as a normal variable. So for me to put a vendor in here, I should include vendor. Sorry. Right? Like that. Yeah. The same way you do Q strings, because these are all classes. All of these are classes. That's a class. Yeah, that's the same way you do your vendor. The only difference is Q string is a predefined class. Vendor is your own class. So I just go private. I want a vendor and call this one vendor. It's a normal variable now. Because the only difference is Q string, that's a predefined one here. Vendor, that's our own one that we created. So here's a vendor inside store item.
Okay.
It's a normal class. The same way you treat Q string, that's the same way you treat vendor. Q string is with functions like size, length, split. Vendor is with functions like get ID, get name, get address. It's a normal class. So there's nothing special about the vendor class that we created. It's just a normal class, just like these existing predefined classes, and you use it exactly like that. So what we've done now is we have added the vendor to our item. Then they say the class should override a method, right? Now remember, whenever we inherit, we are extending a class, which means everything in the base class is now here as well. But what if we want to change how the base class does something, right? So we are saying that if we extend item, that means in store item, we now have all these functions because we extended it. So what your compiler will do is it will just copy, it will just combine item and store item. So all these functions, if you make a variable type store item, these are all part of store item because we extended item. But what if this print details function in item doesn't do exactly what we want? Because this one only does name, ID, price. But the one in store item should do all of that plus the vendor. So we still want a print details function, but it should do something different to the one that we have extended. So what you then do is you repeat that function here. You go, well, void print details like that.
Okay.
And I say, I want to define this function again, even though It's already in item, which I'm inheriting from. I sort of
Mm-hmm.
like want to redo it in store item because it should behave differently. This is what's called overriding because you're
Okay.
saying the function exists in the base. I just
Mm-hmm.
want to override how it behaves. So you repeat it again in your subclass as it is in the base. You don't change one thing. Exactly as it is. You simply repeat it again. When you have done it like this, then it has been overridden. And we can then go ahead and implement, sorry, we can go ahead and implement our function at definition there. Then we can implement it here. And then we can print everything we want to print, how we want to print it. I don't know what I did, but I think I broke it somewhere. Void print details. Why is it complaining? Okay, it's gone. Perfect. So yeah, let's stop here. That's the general concept of classes and inheritance. So in our next class, we want to then finish off this store item, print details. Um, we are not done yet, and talk
Yeah.
about certain concepts of inheritance that are very crucial that we need to understand using this very basic, simple example. And after this example, we're going to then go into more and more inheritance. But it's a recycle of these concepts. And the most important thing right now is to understand exactly what we're doing, extending a class, overriding functions, and what we are going to cover in the next class. All right.
Mm-hmm.
Oh,
Okay.
perfect. Yeah. So let's stop it for now. Yeah, you get the video so you can go through it again if you need to understand something. But otherwise, yeah,
Yeah.
for now, let's stop here. All right. Cool. All right.
Bye.
Cheers. Yeah. I'll see you in the next class.
Okay.
Okay. Bye.